Hello everyone, I'm Shweta. Today we are learning problem solving technique, subject computer science, first semester, session number 35, topic selection by sorting by selection, selection sort. In this session we are learning what is sorting technique. Along with that we will learn about selection sort technique. So, what is sorting? Sorting is nothing but arranging the data in ascending or descending order. So if we have a list of elements and if you want to arrange that elements either in ascending order or a descending order, so in order to do that order, the technique what we follow is called as sorting. So sorting will do the list in ascending order or in descending order. There are so many things in our real life that we need to search for like a particular record in a database, roll numbers in the merit list, or a particular telephone number in your telephone directory, a particular page in a book, etc. So why sorting is required? Think that if you want to search for a particular phone number in your contact list, if it is not sorted, usually we will have a contact number from A to Z, letter A to Z. Think that if the telephone number is not in that order, A to Z order, it is randomly saved, then if you want to search for a particular number, then you need to go from the first record till the last record. But if the phone numbers are in sorted order, then what we can do is it is easy for the person to search for the particular phone number. So that is the reason whatever the data we are having in our mobiles or laptops or in our database, it is a best way to have the data in a sorted order, either in ascending or descending order. All this would have been a mess if the data was kept unordered or unsorted. But fortunately, the concept of sorting came into existence, making it easier for everyone to arrange the data in an order, hence making it easier to search. So, if the data is not in order or if it is unsorted, then it is really a time consuming and very difficult task to find a particular data. So sorting is one of such technique which will help you to sort your data in ascending or descending order, so that it will make your search operation easy. ಸೊ ಸಾರ್ಟಿಂಗ್ ಟೆಕ್ನಿಕ್ ಅನ್ನೋದು ಏನು ಮಾಡುತ್ತೆ ಅಂದರೆ ಲಿಸ್ಟಲ್ಲಿರುವಂಥ ಎಲಿಮೆಂಟ್ನ ಅಸೆಂಡಿಂಗ್ ಅಥವಾ ಡಿಸೆಂಡಿಂಗ್ ಆರ್ಡರಲ್ಲಿ ನಮಗೆ ಅರೇಂಜ್ ಮಾಡಿಕೊಡತ್ತೆ. ಈ ರೀತಿ ಅರೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳೋ ಟೆಕ್ನಿಕ್ನ ಸಾರ್ಟಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. ಸಾರ್ಟಿಂಗ್ ಯಾಕೆ ಬೇಕಂತಂದರೆ, ನಾವು ಯಾವುದೋ ಒಂದು ಸರ್ಚ್ ಆಪ್ರೇಷನ್ ಮಾಡ್ತಿರ್ತೀವಿ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಯಾಕೆ ಸರ್ಚ್ ಮಾಡ್ತೀವಿ ಅಂದರೆ, ಈಗ ನಮ್ಮ ಫೋನಲ್ಲಿರೋ ಟೆಲಿಫೋನ್ ನಂಬರ್ನ ಹುಡುಕ್ಬೇಕಂತಂದರೆ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಅದು ಎ ಟು ಝೆಡ್ ಆರ್ಡ್ರಲ್ಲಿರುತ್ತೆ. ನಮ್ಗೆ ಆವಾಗ ಹುಡ್ಕೋಕ್ಕೆ ನಂಬರ್ನ ಈಸಿ ಆಗುತ್ತೆ. ಇನ್ ಕೇಸ್ ಫೋನ್ ನಂಬರ್ ಎ ಟು ಝೆಡ್ ಆ ಥರ ಸ್ಟೋರ್ ಆಗಿರಲಿಲ್ಲ ಅಂದರೆ ಆವಾಗ ಏನಾಗುತ್ತೆ, ನಮಗೆ ಫೋನ್ ನಂಬರ್ಸ್ನ ಹುಡ್ಕೋಕ್ಕೆ ಕಷ್ಟ ಆಗುತ್ತೆ. ಅದೇ ರೀತಿ ಡೇಟಾಬೇಸಲ್ಲಿರೋ ಡೇಟಾ ಹುಡ್ಕೋಕ್ಕಿರ್ಬೋದು, ಅಥವಾ ಯಾವುದೋ ಒಂದು ಎಕ್ಸೆಲ್ ಶೀಟಲ್ಲಿರುವಂಥ ಕಾಂಟೆಂಟ್ನ ಹುಡ್ಕೋಕ್ಕಿರ್ಬೋದು. ಡೇಟಾ ಸಾರ್ಟೆಡ್ ಆಗಿಲ್ಲ ಅಂದರೆ ನಮಗೇನಾಗುತ್ತೆ, ಹುಡ್ಕೋಕ್ಕೆ ಕಷ್ಟ ಆಗುತ್ತೆ. ಸೊ ಈ ರೀತಿ ಡೇಟಾನ ನಿಮಗೆ ಅಸೆಂಡಿಂಗ್ ಅಥವಾ ಡಿಸೆಂಡಿಂಗ್ ಆರ್ಡ್ರಲ್ಲಿ ಮಾಡಿಕೊಡೋ ಟೆಕ್ನಿಕ್ನ ಸಾರ್ಟಿಂಗ್ ಅಂತ ಕರೀತಾರೆ. ಸಾರ್ಟಿಂಗ್ ಮಾಡೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಸರ್ಚ್ ಆಪ್ರೇಷನ್ ಈಸಿ ಆಗುತ್ತೆ. ಸೊ once again we will say that the arranging the data in ascending or descending order is treated as a sorting operation. So there are mainly two kinds of sorting. One is internal sorting and external sorting. So internal sorting means if all the data that is to be sorted can be adjusted at the time in the main memory, the internal sorting method is being performed. Think that you are performing a sorting operation. Sorting means you are arranging the data in an ascending order. So whenever you will get a larger number, you need to exchange, you need to swap the data. So if all such operations are done at the same time in the main memory, then we call it as internal sorting. If external sorting, when the data that is to be sorted cannot be accommodated in the memory at the same time, and some has to be kept in auxiliary memory such as hard disk, floppy disk, and magnetic tape, etc., then it is called as external sorting. Think that you have a large amount of data, or your sorting method is taking a longer time or a longer memory. Then if the main memory is not sufficient, at that time you have to keep some of the data in your secondary memory or auxiliary memory. If you are performing sorting in such a way, then it is called as external sorting. ಸೊ ಸಾರ್ಟಿಂಗಲ್ಲಿ ಎರಡು ಥರ ಬರುತ್ತೆ, ಒಂದು ಇಂಟರ್ನಲ್ ಸಾರ್ಟಿಂಗ್ ಮತ್ತು ಎಕ್ಸ್ಟರ್ನಲ್ ಸಾರ್ಟಿಂಗ್. ಸೊ ಎಲ್ಲ ಸಾರ್ಟಿಂಗ್ ಆಪ್ರೇಷನ್ ನೀವು ಮಾಡಬೇಕಾದ್ರೆ ಅಷ್ಟು ಡೇಟಾ ಮೇನ್ ಮೆಮೊರಿನಲ್ಲೇ ಇದ್ದು ಅದೇ ಟೈಮಲ್ಲಿ ಸಾರ್ಟಿಂಗ್ ಆದರೆ ಅದನ್ನು ಇಂಟರ್ನಲ್ ಸಾರ್ಟಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. ಇನ್ ಕೇಸ್ ಮೇನ್ ಮೆಮೊರಿನಲ್ಲಿ ಸ್ಪೇಸ್ ಸಾಕಾಗಿಲ್ಲ, ಸೊ ಕೆಲವೊಂದನ್ನು ನಾವು ಆಕ್ಸಿಲರಿ ಮೆಮೊರಿನಲ್ಲಿ ಟೆಂಪ್ರರಿಲಿ ಇಟ್ಟು ಸಾರ್ಟಿಂಗ್ ಆಪ್ರೇಷನ್ ಮಾಡಿದ್ವಿ ಅಂತಂದರೆ ಅದನ್ನು ಎಕ್ಸ್ಟರ್ನಲ್ ಸಾರ್ಟಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. So how to find a sorting efficiency? See, we have so many techniques in order to perform the sorting operation. So out of which one is the efficient one? So we need to find the efficient sorting technique so that you can perform your sorting operation in a effective and time consuming manner. The two main criteria to judge which algorithm is better than the other one: we have time taken to sort the given data and memory space required to do so. Whenever you want to select this sorting algorithm, first we have to see for the time. The algorithm which takes the less time will be the best algorithm. We call it as time complexity. And another criteria what we have to observe is the memory. So if the algorithm is taking the less memory, then again we will tell that this is the best algorithm. So both time and memory will act a major role in selecting the algorithm. If your algorithm is taking a less time and the less memory, certainly that algorithm will act as a best algorithm to perform the sorting operation. ಸೊ ಸಾರ್ಟಿಂಗ್ ಮಾಡಬೇಕಂತಂದರೆ ನಾವು ಎರಡನ್ನ ಕ್ರೈಟೀರಿಯಾನ ಫಸ್ಟ್ ನೋಡಬೇಕಾಗತ್ತೆ, ಒಂದು ಟೈಮ್ ಮತ್ತು ಮೆಮೊರಿ. ಎಷ್ಟೊಂದು ಸಾರ್ಟಿಂಗ್ ಅಲ್ಗಾರಿದಮ್ಸ್ ಇದೆ, ಅದರಲ್ಲಿ ಯಾವ ಅಲ್ಗಾರಿದಮ್ನ ನಾವು ಚೂಸ್ ಮಾಡಬೇಕಂದ್ರೆ ಯಾವ ಅಲ್ಗಾರಿದಮ್ ಕಡಿಮೆ ಟೈಮ್ ತೊಗೊಳುತ್ತೋ ಅಥವಾ ಕಡಿಮೆ ಸ್ಪೇಸ್ ಮೆಮೊರಿ ತೊಗೊಳುತ್ತೋ ಅಂಥ ಅಲ್ಗಾರಿದಮ್ನ ಬೆಸ್ಟ್ ಅಲ್ಗಾರಿದಮ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ along with that, so various sorting techniques are analyzed in a various cases and name these cases as best case, worst case and average case. So if you take the sample of data and you are taking one sorting algorithm to perform the sort operation, so if it is done in a lesser time, you call it as a best case. If it is taking maximum time, then you call it as a worst case. If it is taking average time between the best case and the worst case, then you call it as a average case. So sorting ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅಂದಾಗ ಸೆಟ್ ಆಫ್ ಡೇಟಾ ತೊಗೊಳ್ತೀರಾ ಮತ್ತು ಒಂದು ಸಾರ್ಟಿಂಗ್ ಅಲ್ಗಾರಿದಮ್ ತೊಗೊಳ್ತೀರಾ. ಆ ಅಲ್ಗಾರಿದಮ್ ಡೇಟಾ ಮೇಲೆ ಆಪ್ರೇಟ್ ಆಗ್ತಾಯಿದೆ, ಸಾರ್ಟ್ ಮಾಡ್ತಾಯಿದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಅದು ತುಂಬ ಕಡಿಮೆ ಟೈಮ್ ಮತ್ತು ಕಡಿಮೆ ಮೆಮೊರಿನಲ್ಲೇ ಸಾರ್ಟ್ ಮಾಡಿಕೊಟ್ಬಿಡ್ತಂದರೆ ಯು ಕಾಲ್ ದಟ್ ಒನ್ ಆ್ಯಸ್ ಎ ಬೆಸ್ಟ್ ಕೇಸ್. ಇಲ್ಲ ತುಂಬ ಜಾಸ್ತಿ ಮೆಮೊರಿ ತೊಗೊಳ್ತಾ ಇದೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಟೈಮ್ ತೊಗೊಳ್ತಾ ಇದೆ ಸಾರ್ಟ್ ಮಾಡೋಕ್ಕೆ ಅಂದರೆ ಯು ಕಾಲ್ ಇಟ್ ಆ್ಯಸ್ ಅ ವರ್ಸ್ಟ್ ಕೇಸ್. ಸೊ ಇನ್ ಬಿಟ್ವೀನ್ ಇದೆ, ಸೊ ಬೆಸ್ಟ್ ಕೇಸ್ ಮತ್ತು ವರ್ಸ್ಟ್ ಕೇಸ್ ಮಧ್ಯ ವ್ಯಾಲ್ಯೂನಲ್ಲಿದೆ ಅಂದರೆ ಯು ಕಾಲ್ ಇಟ್ ಆ್ಯಸ್ ಅ ಆ್ಯಾವ್ರೇಜ್ ಕೇಸ್. ಸೊ ಆಲ್ವೇಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಸಿ ದ ಅಲ್ಗಾರಿದಮ್ ವಿಚ್ ವಿಲ್ ಕಮ್ ಅಂಡರ್ ಬೆಸ್ಟ್ ಕೇಸ್. Sorting is nothing but arranging the data in ascending order. Sorting arranges the data in a sequence which makes the searching easier, which we know earlier. Here we have a different sorting techniques like bubble sort, selection sort, insertion sort, merge sort and quick sort, shell sort also. So there are so many algorithms available to perform the sorting operation. So we have to choose the algorithm based on our data. In this session, we will see one sorting technique that is called as a selection sort technique. So the name itself indicates, here you will have the set of data. Out of that set of data, you have to select the data which will form in ascending order. So make sure that you have a list of data. In the list of data, if you are arranging the data in an ascending order, out of the data set of data, you have to choose the smallest number first and you have to place it in first position. Later you have to choose the second smallest element in the list and select that element and place it in the second place. Later the third smallest element. So you have to carry the same procedure to sort n number of elements. In selection sort, the first element in the list is selected and it is compared repeatedly with the remaining elements in the list. So usually you will start from the first element. First we will treat the first element as the minimum element, the smallest element, and it is in sorted order. We treat it in that way and later we start comparing with all other elements. If any element is smaller than the selected element, then both are swapped so that the first position is filled with the smallest element in the sorted order. Later we will start comparing with the other elements of the list. If we find any of the element which is smaller than the first element, then we need to swap both the elements. Next, We will select the element at the second position in the list and it is compared with the remaining elements in the list. If any element is smaller than the selected element, then both are swapped. So once the first element is placed in the right position, we will start comparing with the second element. So if you find any other element is smaller than the second placed element, then we need to do a swapping. This procedure is repeated till the entire list is sorted. So we have to follow the same step until we do comparison and we do sort all the elements of the list. So that same thing is here represented in a steps. So the selection sort algorithm is performed using the following step. The step 1, select the first element of the list. So element at the first position in the list. So as I told you earlier, selection sort, we start the selection, we will select the first element as the minimum element. So you have to start the operation from the first element. Step 2, compare the selected element with all the other elements in the list. Think that I have selected the first element as the minimum element, then I need to compare the first element with other rest of the elements of the list. Step 3, in every comparison, if any element is found smaller than the selected element, then both are need to be swapped. So if I have a first element as the minimum element and when I compare with the rest of the elements, if I find any other element as a smaller element, then we need to perform a swapping between those two positions. Step 4, repeat the same procedure with the elements in the next position in the list till the entire list is sorted. So we have to follow the same procedure until all the elements of the lists are sorted. So here we have an example. We have a list of elements, 9 elements in the list. So that is 29, 72, 98, 13, 87, 66, 52, 51 and 36. So totally 9 elements are there. First, we have to take the first element as a element with the minimum value, that is 29. ಸೊ ಸಾರ್ಟಿಂಗ್ ಸ್ಟಾರ್ಟ್ ಮಾಡುವಾಗ ಫಸ್ಟ್ ಏನು ಮಾಡ್ತೀವಿ, ಮೊದಲನೇ ಎಲಿಮೆಂಟ್ ಯಾವುದಿರುತ್ತೋ ಯಾವುದಾದ್ರೂ ಇರಲಿ ಆ ಎಲಿಮೆಂಟ್ನ ನಾವು ಮಿನಿಮಮ್ ಎಲಿಮೆಂಟ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. So after considering the first element as the minimum element, we start comparing with other elements of the list. So if I compare 29 and 17 to 29 is smallest, 29 and 98, yes 29 is smallest. When I compare 29 with 13, 13 is minimum. Okay, 13 is the minimum element. Then if you compare other elements also, 29 with 87 or 13 is the smallest, then 66, 13 is the smallest, 52, 13 is the smallest, 51, 13 is the smallest, 36, 13 is the smallest. So in the entire list, so 13 is the smallest element. So what we have to do is we need to swap 29 with 13 and 13 with 29. We need to swap that those two particular positions. So 29 ಇರೋ ಜಾಗಕ್ಕೆ 13 ಬರುತ್ತೆ, 13 ಇರೋ ಜಾಗಕ್ಕೆ 29 ಹೋಗುತ್ತೆ. So after the first iteration, we will see that first smallest element is in the first position. Now it is sorted. Now you have to compare from the second element. ಸೊ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಏನಿದೆ ಅದು ಫಸ್ಟ್ ಪೊಸಿಷನಿಗೆ ಬಂದುಬಿಟ್ಟಿದೆ. ಈಗ ಕಂಪ್ಯಾರಿಸನ್ ಯಾವಾಗಲೂ ಏನಿಂದರೆ ಸೆಕೆಂಡ್ ಎಲಿಮೆಂಟಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು. ಸೆಕೆಂಡ್ ಎಲಿಮೆಂಟ್, think that 72. So again compare that 72 with the rest of the elements, 98, 29, 87, 66, 52, 51 and 36. Out of it, 29 is the smallest one. So again what we need to do is we need to swap 72 with 29, 29 with 72. So rest of the elements na compare ಮಾಡಿದಾಗ 29 smallest element ಆಗಿತ್ತು. ಸೊ ಆವಾಗ ಏನು ಮಾಡ್ತೀವಿ, 72 and 29ನ ಸ್ವ್ಯಾಪ್ ಮಾಡ್ತೀವಿ. ದಿಗೆ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ದ ಥರ್ಡ್ ಎಲಿಮೆಂಟ್. ಸೊ ಥರ್ಡ್ ಎಲಿಮೆಂಟಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದಾಗ 98 ಇದೆ, 98ನ ಬೇರೆ ಎಲಿಮೆಂಟ್ಸ್ ಜೊತೆ ಕಂಪೇರ್ ಮಾಡೋಣ. ಸೊ 72, 87, 66, 52, 51 and 36. Out of all the other elements, 36 is the smallest one. So what we need to do is we need to swap the 36 with 98, 98 with 36. Now you observe, first three elements of the list are sorted, that is 13, 29 and 36. These three elements are sorted. Then again compare with the next element, that is 72. So keeping the 72 in a position, compare the other elements, that is 87, 66, 52, 51 and 98. Out of it, 51 is the smallest one. Again do swapping. swap 51 with the 72, 72 with the 51. So now you can observe first four elements are in sorted order, that is 13, 29, 36, and 51. Now compare 87 with rest of the elements, that is 66, 52, 72, 98. So out of it 52 is the smallest element, again do swapping with 87 and 52, and observe that first five elements are sorted. The next element will be 66. Compare 66 with 87, 72, 98. 66 itself is the smallest number. At that time, no need to do any swapping. ಸೊ 66ನ ಇನ್ನು ಮಿಕ್ಕಿದ ಮೂರು ಎಲಿಮೆಂಟ್ ಜೊತೆ ಕಂಪೇರ್ ಮಾಡಿದಾಗ 66 ಸ್ಮಾಲೆಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಆಗಿದೆ. ಹಾಗಾಗಿ ಯಾವುದನ್ನು ಸ್ವ್ಯಾಪ್ ಮಾಡೋ ನೆಸೆಸಿಟಿ ಇಲ್ಲ. ಅದೇ ಪೊಸಿಷನಲ್ಲಿ 66ನ ಇಟ್ಟು ಯು ಕ್ಯಾನ್ ಮೂವ್ ಟು ದ ನೆಕ್ಸ್ಟ್ value, that is 87. Now compare 87 with 72 and 98. Out of it, so 72 is the smallest number, so you need to do a swapping of 87 and 72. Then compare with 87 and 98. So 87 itself is the smallest number, so no need to do any swapping, and the last value is in its right position. So now you can observe all the elements are in sorted order, that is 13, 29, 36, 51, 52, 66, 72, 87, and 98. So all the elements are in sorted order. So this is how selection sort will work. First you have to select the first element as the minimum element, compare that element with the rest of the elements. Whichever the element is minimum, then you need to swap both the elements. So you need to carry on the same procedure until all the elements will come in sorted order. So here is an algorithm. Start from 0 to n minus 1. So in each iteration, first position, whatever the first value is there, you keep it in a position, POS, or you can keep it as a minimum. From the next element, you need to start a comparison, that is I plus 1, it should be less than n, j plus plus. If you find any of the time, if you find that your first element is larger than the any other element, that is a of pos is greater than a of j, then you have to consider j as the smallest one. So store it in POS, position. ಸೊ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಇಟ್ಕೊಂಡಿರ್ತೀರ, ಪೊಸಿಷನ್ ಅಂತ ಇಟ್ಕೊಂಡಿದ್ದೀರಾ. ಅದು ಬಿಟ್ಟು ನೆಕ್ಸ್ಟ್ ಯಾವುದೇ ಎಲಿಮೆಂಟು ನಿಮಗೆ ಸ್ಮಾಲರ್ ಸಿಕ್ತು ಅಂದರೆ ಆ ಸ್ಮಾಲರ್ ಎಲಿಮೆಂಟ್ನ ಪೊಸಿಷನಿಗೆ ಹಾಕೋಬೇಕು. ದಿಸ್ ಶುಡ್ ಬಿ ರಿಪೀಟೆಡ್ ಅಂಟಿಲ್ ಯು ಗೆಟ್ ದ n number of elements. So if the position is not equal to I, then you need to swap. So if you find any of the element, the smaller as a smaller element than your first position element, then you have to do a swapping of a of I to swap a of position to a of I and swap to position. So your I element will come in the position and position element will go to your ith element. So that is how the swapping will be done. So points to be remembered for selection sort. Sorting is nothing but arranging the data in ascending or descending order. Sorting arranges the data in a sequence which makes searching easier. So we will perform the ascending or descending order in the sorting. So if you do sorting, then it will be easier to perform a searching operation. In selection sort, the first element in the list is selected and it is compared repeatedly with all the remaining elements in the list. So in selection sort, first we will consider the first element as a minimum element or in a position. Then we start comparing the first element with the rest of the elements in the list. If any element is smaller than the selection element or the first element, whatever the element you have selected for ascending order, then both are swapped so that the first position is filled with the smallest element in the sorted order. So once you start comparing the first element with other elements in the list, if you find any of the other elements are smaller minimum, then you need to do swapping of both the elements, and these steps need to be repeated until all the elements of the lists are sorted. So this completes about sorting technique, a selection sort. Thank you.